In this video, we're going to do a little bit more with sets, and two big terms that we're going to see are the intersection and union of sets. And so we have a notation here, an upside down U, which really intersection means and. So if you think about a street intersection, that's where two streets meet. So you can be on both streets at the same time. Picture-wise, if I'm going to say, okay, here is set A and here is set B, where they overlap, I'll call that like the and part, that's the intersection. So A intersected with B is all of those things that they have to be in A, they have to be an element of A, and an element of B at the same time. For union, what we're saying, and it's represented with U, is or. So if I have, again, that's kind of same picture, we're saying, okay, you could live in A or you could live in B, or you could even live in both. So as long as you're somewhere here, you're in the union. So A union B. You have to be X is in A or X is in B. And again, that or word could be in both. If you're in the intersection, you're in the union. So for example, we have these two sets. A is a set 1, 2, 3, 4, 5, 6, and B is 2, 4, 6, 8. So if we want their intersection, what we're looking for is what's going to appear in both. So 2 is in both, 4 is in both, and 6 is in both. So the intersection, A intersect B, would be those elements, 2, 4, and 6. Erase that and now look at union. So union is you have to be in A or you have to be in B. So you could be 1, 2, 3, 4, 5, or 6, or you could be 2. Well, we already said that, but so I'm not going to write it twice. Or you could be 4, which again we already said that, and 6, we already said that, so we don't have to write that twice. But 8's a new guy, so we're going to have 1, 2, 3, 4, 5, 6, and then we're going to throw 8 in there as well. This is the union. So I'll write A, U, B. So now using this knowledge of intersection and union, we could make a Venn diagram to kind of show what sets we're talking about. So when we're asked this question here, it says, is this set equal to this set? Well, it doesn't tell me what the actual elements are, so we could do it by picture. And so if I want to know what that first picture is, so let's look at the left side here. It has an A, a B, and a C. So anytime you have three sets, it's often really common to draw it like this. So we have A and B and C. And I'm going to work with parentheses first, just like an order of operations. So that would be looking at the intersection of A and B. Well, that's going to be this part right here in the middle. So then it says, okay, just thinking about that part, that was our parentheses, we need to intersect that with C. Well, the only part where that touches with C is going to be right there, that part. So that is the entire thing. A intersected with B and then intersected with C. So let's see what's going on the other side. So again, I'm going to draw A and B and C, and make sure you put them in the same spots, A, B, C. And this time, it wants me to intersect B and C first. So B and C intersected would be this little segment. And then they say, okay, well, let's intersect that with A. So where does that green part hit A? It only hits right here. So those are actually the same exact section. So as long as it's the same region, then we're going to be able to say, yeah, they're equal. For the next one, again, we have three sets, A, B, and C. Just kind of stick to that order. I'm going to draw the pictures already for both of those, A, B, and C. Okay, so again, going with parentheses first. A intersected with B. That's going to be this little section here. Now it wants to union that with C. So remember, union means or. So you got to live in that current red part, or you live in C. So I'm just going to put that together. And so you got to live somewhere in that red part, in the intersection or in C. Let's compare that to the right side. It starts by looking at B union C. Well, that again means you're either in B or C or both. That's going to be anywhere in B or anywhere in C or anywhere in the intersection. So anywhere in there. Now it wants us to intersect that with A. Well, A, you can see, is the big circle. It's only intersecting that green part right here. So if you compare the two regions right now, those are for sure not the same region, so this is not equal. And what that's kind of showing is that you can't just move parentheses around when you have different set operations. Union and intersection are different. If they're all the same, you can see we had all intersections here. It looks like you can move parentheses around. So now since we know just looking at the regions that they're not the same, it said to give a counterexample to show if they're not going to be equal. Remember, counterexample means that you're going to show that it's false, and we're going to show it with an actual set. So let's pick some sets here. Let's say A is equal to A, B, C, B is equal to set C, D, and let's say C is equal to D, E, F. So if I do the operations, let's look at the left side first. The left side said we have A intersected with B and then put with C. So here in this example, A intersected with B, these two guys, their intersection is C. So I'm going to make a little C. So we want to union that with our big set C, where our big set C is D, E, F. So I'm going to write that in there, D, E, F. So if we union those together, it just means put them all together, C, D, E, F. So that right there is the intersection of A and B unioned with C. Now let's go the other way. Let's look at the right side. A intersected with B union C. Let's go to the parenthesis first, B union C. So that's putting B and C all together. So we have C, D is duplicated, that's fine, E, F. So C, D, E, F. Now we want to intersect that with A. I'm going to write out set A, which is A, B, C. And what's their intersection? It's just C. So you can see that that right side is just that element, or just a set with what one element C, but the left side contained 4 elements. So there's no way that those could be equal to each other. And so this would be a counter example. It's showing that this is false. The statement here is not true. All right, we have 2 other words in here. We have a relative complement and the Cartesian product. Let's look at the relative complement. It kind of looks like a subtraction. It's a good way to think about it. So it says that X has to be an element in B, and it kind of printed weird, this should be an element not in A. So we write that X is not an element of A. Picture is a good way to show this. So if we have, you have to be in B, but you can't be in A. So if I draw, I'm going to make a box for my whole universe, and I'm going to have A and B in it. A and B. So you have to be in B, but not in A. So what that's talking about is all of this portion. So it's B, and it's like this guy here got kicked out. I took him out, minused out. And so that's why we don't include that section in the middle. You could also think about this as the complement of A, so everything not in A, where that intersects with B. These are the same. Now the Cartesian product turns things into ordered pairs. So for example, it's kind of the best way to show it. If you have the set A is 2, 4, 6, and you have set B is 2 and 3. What the Cartesian product, written A cross B, is it has to write as ordered pairs. The first element, X, has to come from A. The second element, Y, has to come from B. So let's see, I'm going to put 2, this 2, with this 2. So that will be 2, 2. Then I'm going to take that same 2, but put it with 3. So I'm going to have 2 with 3. Now I'm going to move over to my next element, just trying to make a little order here. So 4 with 2. That's going to be 4, 2. Then I'm going to take 4 with 3. So that would be 4, 3. And then I'm going to take the last guy, 6 with 2, which is 6, 2, and 6 with that 3, which makes 6, 3. And so I'm going to put commas between all these little ordered pairs, and that's my new set. The Cartesian product creates a new set. That is a bunch of ordered pairs made up of those previous 2 sets. All right, using a lot of this new notation and symbols, vocabulary, we're going to try and find a whole bunch of different relationships between these sets A, B, C, and D. We're given that the universe is the alphabet. And we have set A, which is ABC, B, which is AEIOU, C, where it says X is a consonant. So just in case you're not sure, this first set B is all the vowels. And these consonants mean all the things that are not vowels, like A, B, C, D, skip the vowel E. So then F, G, H, skip the I, and so on. And then D is the set X, Y, Z. So these are the not vowels. And we'll include Y as a consonant, so Y is in there. So we could find a whole bunch of things. Let's see if we found, I'm going to actually make a list and then let you try and guess through them. And then you can come back and watch the video. So here we go. I'm going to have you find N of A, N of C, All right, so right now you should kind of pause the screen and try 1 through 10, see if you can figure out what they are. Try it first, then come back and unpause and see what the answers are. So now that you tried, coming back, N of A means the cardinal number for A, or the number of elements of A. That should just be 3. N of C, that's the cardinality of C. Well, that's the number of consonants. So there's actually 26 consonants, 26 letters in the alphabet, minus the 5 vowels. So there's going to be 21 consonants. N of U, that's our universe. So we already said that. There's 26 letters. A intersected with B, that's the element that A and B have in common, which here the only thing they have in common is A. The union of B, that's just putting A and B together. They have the A in common, so don't write that twice, but I'll just write A, B, C, and then E, I, O, and U. And then we have the complement of C. Well, if C is all of the consonants, then its complement would be the other things that make up the alphabet, which would be B. Or you can write it as a set if you want. A, E, I, O, and U. Now the number of subsets of B. Remember we said that however many elements are in B, it's 2 to the n. So if there's n elements, there's 2 to the n subsets. You could write them all out, but it's easier if you remember that. So if there's 5 elements, it's going to be 2 to the 5th, which is 32. Now B minus C, or we've called that the relative complement. So basically B take out C. Well, there's nothing to take out, so you're just going to be left with B. U take away C, well, that's just going to be the vowels. I'm going to add in a problem right here. I'm going to add it as number 11. How about B minus A? Well, if you take away set A, the only thing they had in common was the little letter A, so that would just leave you with E, I, O, U. And then I skipped number 10, the Cartesian product A cross D. Remember, that's just going to be a whole bunch of ordered pairs. So we have set ABC. If I go back, ABC, crossing that with XYZ. So I'm going to put A with each element in there. And then I'm going to put B with each element in D. And C will go with everybody. There we go. We've listed all of the ordered pairs that could be made up where an element from A is the first component and an element from D is the second component. And there's tons more other relationships that we could write, so there's just a few there that you had tried. Now, kind of putting this all together into an applied problem is this situation here. So it tells me all of these details about our students that were taking physics, bio, and math, and then it starts to ask me questions. Well, how many took bio but didn't take physics nor math? Or how many took physics, biology, or math? Or how many didn't take any of the 3 subjects? And so those were kind of some deep questions. Looking at all those numbers, it's like, how do we figure that out? Well, it's really helpful to do a Venn diagram. So there's 2 examples on this page. I'm going to try and walk you through one, and then I want you to try the second one all by yourself first, and then check back with the answer. So the first thing that I want to notice is in the explanation here, it tells me that a survey was investigated the high school backgrounds of 110 college freshmen. So this is going to become my universe. So if I'm going to draw my Venn diagram, I'm going to make my big rectangle to contain my sets, but I know the total for this rectangle has to be 110. So there has to be 110 things living inside of it. Now students took physics, bio, or math, so I'm going to draw 3 circles to represent the sets of people that are taking the physics, the bio, and the math. You could call them sets A, B, and C, but I'm going to use the letter for the subject, so P for physics, B for bio, and M for math. Now it kind of starts with the big picture. When you see 25 students took physics, that means that the entire circle here has to be 25 people. And if you look at the next view, again, you know the whole circle. But if you go down to the bottom where the smaller number kind of sits, it says 5 people took all 3 subjects. Really, that's telling you that there's 5 people that live in the intersection, because those 5 people are in each of those circles. And then we can kind of try and expand from there. Well, it says 6 people took physics and biology. So physics and biology is this section right here. Well, it says 6 people live in there. Well, I already have 5 people in there, so that means that 1 person has to be in that little section there. Then it says 8 people took bio and math. Well, bio and math is right here, but I have 5 people already sitting in there, and so I need to make 8. That would mean 3 people would have to be in that section. So that way that total, if you add 5 and 3 together, that's 8. Then it says that there are 10 people that took physics and math. So that means 10 people need to live inside there. Well, again, there's already 5. So that means that there would have to be 5 in this little section. So 5 plus 5 makes 10. Then it tells me that there are 48 people that took math. So now I know the entire circle of math people, this all has to add up to a total of 48. Well, I already have 13, so that means that this would have to be 35 more, because 48 minus those 13 that we already have recorded is 35. Then when I go over to the next section for biology, this total circle has to be 45. Well, it already adds to 9. So if I take 45 minus the 9, then that's going to be 36. So I have 36 people living in that section. Lastly, it says 25 people took physics, so that means there's 25 people living in that section. Again, there's 11 already accounted for, right? There's 5, 5, and 1. And so if I take 25 physics students minus those 11 that are already hanging out because they're taking other subjects as well, then I'm going to end up with 14. So there'll be 14 people living in there. So now all the people, if I add up all of those totals together, the total 14 plus 1 plus 5 plus 5, again that should be the physics people, so that's 25. And then I add, let's take the 25, we're going to add the 36 and 3. I don't want to add the 1 and 5 again, so it'll be 25 plus 36 plus 3. Which equals 64. And then who did I forget? Oh, the 35 guy. So 64 plus the 35 equals 99. So however you want to add those, the total so far that I have is 99. Now remember, we said that there was supposed to be 110 college freshmen that we're talking about in this survey. So what's going on with them? Well, they don't take physics, bio, or math. They're living outside of those circles. So 110 minus those 99 leaves us with 11. So there's 11 people that would be living out there. They're not sitting inside any of those circles. So this is a Venn diagram to represent all these people and what they're taking and stuff. And so it should be really a lot easier to answer the questions. So it says, how many people took bio, but they didn't take physics or math? So we're talking about they couldn't be in here because those are physics people, and they can't be in here because those are math people, so all that's left over is the 36. Then it says, how many took physics, biology, or math? Well, we actually added that all up. All the people in any of those circles, it could be in intersections or not, we already said was 99. Now, how many did not take any of the 3 subjects? Well, that ends up being that 11, those leftover people that we had to figure out added up to 110. So now you should try the next one, give it a shot, see what you can come up with. Now that you had paused it and tried, you can see I have a Venn diagram written out for the history, English, and math people, or the people that like those subjects. And it says the same information kind of as up above, but it wrote it in a whole little paragraph. I'm still kind of inclined to go towards like the last part of that paragraph, which says that 3 people like all 3 subjects. So that way I can fill in my Venn diagram kind of from the middle out. So I'm going to put 3 people in the middle, since 3 people like all of those subjects, and then work my way out. So it says 7 people liked history and math. So history and math is right here. And so that has to be a total of 7, which makes there be 4 in here, because there are 7 minus the 3 that are already written. Then it says that there are 5 people that liked history and English. So history and English is this. It says there's 5 people that live in there. Well, there's already 3 used up, so that makes 2. So again, I'm just doing 5 minus 3 equals the 2. Next, it says that there are 8 people that like math and English. So math and English is going to be that little section. And so that needs to total 8. So 8 minus a 3 equals 5. So there would be 5 people living in there. Then it says that there are 18 people that like math. Again, we need to look at this entire circle here. Has to add up to 18. Well, I already can add up the numbers inside. The numbers inside add up to, let's see, 4 plus 3 is 7, and then 5 more. That's going to be 12. So the total math people, it's 18 minus the 12 we used up, that leaves 6. So 6 people will live there. Then I want to look at the 18 that liked English. So again, that's filling up the English circle. This has to add up to 19. So far, it already used up, let's see, 2 plus 3 is 5, plus 5 more, that's 10. So the total English is 19 minus 10. That would leave a 9. So there's going to be 9 people living in there. And then the last guy here, we have 16 people like history. The history circle has to add up to 16. Again, I already have 4 and 3, that's 7, plus 2 more, that's 9. So for history, 16 minus 9 leaves 7. So there's going to be 7 people that live out there. So that's what the Venn diagram should be looking like for you. So when it says how many students were in the survey, well, it did say, and I just realized I skipped it, it said every student liked at least one subject. So that means there's nobody that was living outside of there. So how many students were in the survey? Well, we can add up all of those numbers that you see. So just like kind of starting with the English, we know that there were a total of 19 people in there. Then we'll add in the 6 from the math there. We can add in the 4 that were kind of in that middle but not including the 3. And then we could add 7, which is going to be 36 altogether. So there were 36 people in the survey. So how many students only like English? Well, that's talking about those little outside guys. They're not in the history or math circles, just English, that's 9. How many like English and math, but they don't like history? So English and math, I am now drawn to this little 8-pack of people, and it says they can't like history, so we don't want those 3, so it's only going to be those 5 in the middle there. So there's just some strategy to using those intersections and unions and trying to use the Venn diagram to figure out an application.